Hello everyone. So I am Arshu Upadhyay and I am presenting 8086 Microprocessor Architecture from MPCO subject. Now let's understand basically the overview of this presentation. Firstly, the introduction of 8086, the difference between 8085 and 8086. Now basic understanding the segments of 8086, components of each segments, which are types of segments, utility of each component and basic working. Now, introduction to 8086. Firstly, it consists of powerful instruction set. It provides operations like multiplication, division, any of the shift operations which easily and faster. Also, it supports two modes of operation: maximum mode and minimum mode. The maximum mode is suitable for system having multiple processors, and minimum mode is suitable for system having single processor. Now 8085 and 8086. So 8086 is simply we can say the advanced version of 8085 processors, and every feature of 8085 in an increased manner in 808 8086. So we will see here 8086 is an advanced version. Okay, as 8085 is 8-bit, and but 8086 is 16-bit microprocessor. Okay, and 8085 has 16-bit bus present. Increase to it, 8086 has 20-bit bus present. Now, 8085 has potential accessible memory capacity of 64 kilobytes or 216 bytes. In 8086, accessible memory that can hold is 1 megabyte or 220 bytes. Okay. Now, next. Now we are understanding the two major units, or we can say segments, of 8086 architecture. That is the bus segment unit and the execution unit. Now, the bus segment unit basically contains the bus and which decodes, and execution unit executes the instruction given. So, moving further to it, the components of segments. BIU bus segment. BIU segment, bus segment. It contains instruction stream byte queue, which is 6 byte, which is placed just here. It now contains in this example. It contains 6 registers, which we can say 6 control stream byte, and segment registers. Segment register basically contain the multiple types of registers, which we will explain it further. I will explain it further. Now, the third component is the physical address identifier. The physical address identifier basically generates or creates the address by via memory interface. Okay. Now, moving further to the another component, the execution unit. It contains control statement, which is the major component of whole 8086 microprocessor. Now, it it is here. So, the instruction stream by queue directly approaches to the control system and further moves to the ALU. Now, the control system basically performs all the controlling tasks, which we will explain further. The set of general purpose registers, the set of pointers in BIU. Okay, so this is the set of general purpose registers, and these are the pointers which we'll be using for accessing the registers. Now, it also contains ALU, which is basic arithmetic and logic unit here. So we will use it further. Moving further to it, so this is the basic architecture of 8086 microprocessor. So this is the memory interface I was talking earlier. So the memory interface directly goes to the physical address identifier. It um, generates of the instruction, or we can say the operands, which we will fetching afterwards. So VIO segments. The working of the usage of VIO, it fetches the instructions and takes the data in the form of physical address. The physical now we will understand each of the components uh, utility. Okay, so first, instruction stream by queue. The use for it is used for prefetch. the part of pipeline. The prefetch is a part of pipelining where the instruction after executing the next instruction is already will be in a type of buffer or another register stored, so it don't have to be fetched from the memory directly, and the time will be saved. Okay. So it works on the FIFO manner. Obviously the registers have to be worked on FIFO manner. The instruction first given will be executed first. Now the prefetch instruction are stored in the form of high speed registers. So this is the basic instruction stream byte queue. Here it is. We can see it. In this example, there are also there are six registers. Now, next, moving further to it, the segment registers. In segment register, there are four different type of registers, each of 16 bits. 20 bits of address line accessing 1 MB of memory. So, we will now uh, understand the ES, CS, SSS, SS, and DS IP operation pointers and segment registers. So these are the basic types of ES means extra segment, CS means code segment register, SS means stack segment register, DS means data segment register, IP means instruction pointer. Instruction pointer is used for accessing the four of the registers which are pointing towards the another unit. PA identifier. The PA identifier generates 20-bit address using segments and registers and offset pointer register. So it basically contains a formula of physical address, which is SR multiplied by 10H minus OP. Sorry, plus OP. Okay. Moving further to it, execution unit. It does not require a bus system because it just executes the given instruction. The instruction will be in a bus counter. Okay. So after using in bus, it direct transfers it into execution unit, and it just executes using ALU and multiple registers, which we will learn in this slide. And the control unit controls which type of instructions are further used. Okay, so executes the instruction passed by BIU, as I said earlier. So control system. It is used to provide system control signal, which is read, write, or we can say also say append to all the other component in the architecture. It can be used as 4-bit, 8-bit, and further 16-bit or 32-bit extent. Okay, now AH and BH, CH, and DL. Okay, so these all are the registers, and AL, BL, CL, DL are the, we can say, the pointers, or we can say the helping registers in some kind, helping registers for moving or accessing the data into AH, BH, CH, and DH. Okay, the set of pointers in which there is a stack pointer and base pointer. Okay, the stack pointer is used for top of stack, and base pointer points in any part of stack. Okay, source index and destination index. The SI points to the data segment in BIU, as I said earlier. This BIU SI segment just directly points to the here register unit. Also, now BIU and DI points to the extra segment. Okay, the ALU. All the arithmetic and logical operations, if any operations are executed in the operation, flags will be get modified, and all the arithmetic and logical tasks are performed. As we can say, in a basic arithmetic logic unit works is basically the reflection of this ALU given. Okay, now we will summarize the part. So in in this 8085 microprocessor, basically there are two segments, the two segments, bus intersection interface unit and execution unit. Bus interface unit fetches the instruction, and execution unit, uh, we can say, executes the instruction. Okay, now bus intersection unit contain components like physical address, register interfaces, and instruction stream byte queue. Instruction stream byte queue basically is the array, or we can say stack, of basically the instructions given in the form of array. Okay, so this physical address identifier generates the address pointer via memory interface. This the segment registers are used for multiple accessing units, and the IP pointer is used for accessing all the registers. Now, now moving to the execution unit, the AH, BH, CH, and DH are the registers, and AL, BL, CL, DL are the ALBLCL are the pointers or type of pointers or registers we can say are used for accessing the data. Now SP and BP are the two registers, and SI and DI are the another set of pointers in this whole unit. Okay. Now we will contain the ALU ALU part of the part. So ALU is basically the reflection of basic arithmetic and logic unit. Okay, and the basically now contains the control system is the basically the most major part of the whole 8086 microprocessor. So that was all about it.